Hello, calculus fans. Let's evaluate this line integral. The field is x squared minus y squared, comma x, and the curve is the positively oriented boundary of the sector of the circle of radius 3 occupying all but the fourth quadrant. So maybe that's a somewhat confusing description. Let's look at the picture, then refer back to this description. I think you'll see that it's actually pretty straightforward. This is the region that we're talking about. Notice that it's a sector of a circle, radius 3, occupies all but the fourth quadrant. So you can see down here the fourth quadrant portion of the disk is missing. The red that you see is the boundary of this region, and of course we're going to follow this curve in a counterclockwise direction. So that means we're going to go along the curve like this. Now we could evaluate this line integral directly, but in order to do that we'd have to break it up into three pieces. The circle, or at least the portion of the circle, the vertical line segment, and the horizontal line segment. And that's three separate integrals that we'd have to evaluate. Instead, what we're going to do is make this calculation a lot easier by using Green's theorem. Also, when we evaluate this double integral, we're going to use polar coordinates. That should be clear from the nature of the region being a sector of a disk. We're going to let p of xy be x squared minus y squared, and q of xy will be x. So, by Green's theorem, the line integral is equal to the double integral over d of dq dx minus dp dy. dq dx is just 1. dp dy is negative 2y, and that's why that turns into 1 plus 2y. So there's a minus minus in there. Now we're going to rewrite everything in polar coordinates. So theta goes from 0 to 3 pi over 2. That's because it's 3/4 of a disk. R goes from 0 to 3, since that's the radius of the disk. Then we'll have 1 plus 2r sine theta. So what you should see here is that 1 plus 2y turns into 1 plus 2r sine theta. And then we always have the r dr d theta at the end. We distribute the r. Then we have an antiderivative with respect to r, and we've got to plug in the 0 and the 3. Now we'll get 9/2 plus 18 sine theta. If we anti-differentiate with respect to theta, we'll get 9 theta over 2 minus 18 cosine theta. Work all that out, and we'll end up with 27 pi over 4 plus 18. Okay, that's all for now.